section that you do not color all the way to the tail, just to this far. Okay. What does 2.35 and 2.35 add up to?
4.7.
4.7 plus the 95 we already had makes 99.7. 99.7% of the data is within 3 standard deviations of the mean. And then underneath the 99.7, I want you to use all 3 of the colors. The middle color, the second color, and the final color. How come this isn't 100%? Yeah. And it doesn't just go to here. Remember, it stretches out really far. It gets tinier and tinier and tinier and tinier. Officially, anyone that is beyond 2 standard deviations is considered an outlier. So blue and on for me would be outliers over here, and blue and on would be outliers over here. Okay. How do you feel about this? You do not have to memorize this. You'll be able to use it on any test. Okay, let's put an example on the back, so flip it over. This is 2.4, the last section of 2.4. The empirical rule. And today is 11/8. Okay. We're going to do just one example that I think will help you. Ladies' heights in America have a mean of 64.2 and a standard deviation of 2.9 inches. Okay, so I want to know what percent of women are between 58.4 and 64.2 inches tall. I think this is actually wrong. I know this is correct data, but I think I'm wrong about it being in America. I think it's just ladies' heights all over the world. Because in America, we tend to run taller than other places. Anybody know what 64.2 is in feet and inches? 5'4" is the average, which means I'm below average. Surprise, but not an outlier. Okay, but I guess if you think about the whole world, it starts to make a little bit more sense. There's a lot of people in, especially Asian countries, that have smaller, shorter people than we do. Okay, so let's draw a bell curve. This is the part where you get to make fun of yourself. Go ahead and give it a shot. Try drawing something that looks symmetric. Hey, that one was pretty good. Good luck.
Yeah, I can just follow the marker blade through.
Oh, nice.
Yeah, that's right.
Then draw a line down the center. What is in the center?
Average.
The average. I'm going to write 64.2 here. That's the average for ladies. Our standard deviation is 2.9, so I'm going to draw in 3 sections. 1, 2, 3. 1, 2, 3. I'm going to grab my calculator. Tomorrow, by the way, will be a work day to finish up this 2.4 assignment and to check it in. I'm also going to have any, if we have any like missing homework or retakes or collecting warm-ups, just end of the quarter stuff tomorrow. Huh?
That's the end of the quarter.
Yeah. 64.2 plus 2.9 is 67.1, plus another 2.9 is 70, plus another 2.9 is 72.9. Who's our tallest lady in here? Is it you? How tall are you, Jessica? 5'6". How tall are you? 5'7". 5'5.5". All right, so you're 5'7". So you would be 67 inches tall. So all 3 of our ladies are here in this section, except for me. I'm in that section. But look, we're within 1 standard deviation of the mean. We're not extremes here, right? We're not going off to extremes. I'm going to take 64.2 minus 2.9, which is 61.3, minus another 2.9, 58.4, and then minus another 2.9, 55.5. You don't have to do this for every problem. And if you're wondering right now, whoa, how crazy is it that 58.4 and 64.2 happen to be on here? It's not crazy. It's going to be exactly like that because all you know so far is the imperial rule, right? Next section, I'll teach you how to find z-scores, which means that we'll be able to find how many standard deviations away any piece of data is to the nearest like hundredth. But right now, we only have 1 standard deviation, 2 standard deviations, 3, -1, -2, -3. So it looks like we're talking about this group. We're talking about between here and here. So what percents are in there? Anybody remember, or just flip it over? 34% here. And 13.5 here. So this would be what? 47.5% of women are between this and this. So on your homework, I'm going to add in this page. Let's look at what I've already assigned you so far. Okay, tell me what I already had.
13.
Was it page 93?
93.